Today, on how it's made. Ice cream treats. They sure take a licking. Wooden golf clubs. Different strokes for traditionally minded folks. Aircraft wings. Their construction plain and simple. And car battery recycling. On this production line, they really get the lead out. Before refrigeration, ice cream was a handmade luxury. They placed the ingredients in a mixing bowl in a tub filled with ice and salt water. The salt helped the ice absorb heat, cooling the mixture below the freezing point. In the 1920s, commercial freezers made mass production possible, launching the ice cream industry. To make these ice cream treats, you must first make the ice cream. It all begins with fresh cream. The factory stores the cream in refrigerated silos set to a constant 4 degrees Celsius. The silos feed a high-speed mixer that blends it with the other ingredients. The main dry ingredients are powdered skim milk and plant-based stabilizers and emulsifiers. Stabilizers prevent the ice cream from crystallizing, and emulsifiers allow the mix to bond with air during the whipping process. The other ingredients are sugar and corn syrup. After about 3 minutes of mixing, a pumping system moves the mixture into large pasteurization tanks. The tanks keep the mixture at 72 degrees Celsius for half an hour, killing any bacteria and activating the stabilizers. Then the factory homogenizes the mixture, a process that breaks up the fat globules, giving the ice cream a smooth texture. They cool the mixture and add concentrated vanilla flavoring. Then they chill and whip everything for about 15 seconds. Whipping blends the mix with air, transforming it from a liquid to a soft solid. Without air, it would come out looking like frozen milk rather than ice cream. The ice cream sandwich wafers are made of chocolate cake ingredients. A filling machine feeds 2 lines of wafers towards an injection pipe in the center. Just as 2 wafers come together, the machine injects 80 milliliters of vanilla ice cream in between. The pipe's head shapes the ice cream into a rectangular slab that fits perfectly between the wafers. All this happens at a rate of 140 ice cream sandwiches per minute. As the sandwiches move on to packaging, the filling is still ice cold from the freezing phase, so there's no threat of it melting. The packaging system raises each sandwich into a wrapper, then folds and tucks the ends. The next machine counts the sandwiches and inserts them in boxes. Once sealed, the boxes go directly into a storage freezer at -30 degrees Celsius. On another line, ice cream cone production is underway. A feeder drops pre-wrapped sugar cones into holders on a conveyor belt. They first pass under sprayers that coat the inside with a chocolatey coating which adds flavor and creates a barrier between the cone and ice cream, so the cone remains crispy until you eat it. Next, nozzles squirt in the ice cream filling, 78 milliliters per cone. 1 production line, 2 flavors. 1 row of cones gets vanilla ice cream, the other row chocolate. Now for a tasty surprise in the cone's core, an injection of liquid caramel. This factory also makes ice cream cones with chocolate and strawberry sauce inside. Next, a chocolate-flavored liquid topping. Then the crunchy finishing touch, a layer of chocolatey-coated puffed rice. Finally, the cones move under a lid dispenser. It applies a wax-coated paper lid to each one. A heating element instantly melts the wax, sealing the lid to the cone's paper sleeve. From here, the ice cream cones go into boxes, then straight into the freezer, ready to take a licking. High-tech metal golf clubs now rule the greens, but don't count wooden clubs out of the game yet. Wooden golf clubs are all about tradition. Golfers have played with them for centuries, and some still prefer the look and feel of wooden club heads, any way you slice it. With a good-looking wooden club, your luck could be on the upswing. Each club head starts with a log of persimmon wood, which is a type of ebony. They slice it into quarters and discard the center section because it's lower quality. They cut one of the quarters down to a workable shape and size, then lock it into this duplicating machine. Overhead, they place a more sculpted piece of wood, called a master model. As they turn, a wheel traces the contours of the master model and guides a blade below, which carves the rough chunk of wood into a duplicate of the master model. They switch master models to one that looks a lot more like a golf club head. Again, the blade below copies the shape. They cut the stub off the duplicate, and they smooth it with a light sanding. Next, using a spinning cutter, they carve a generous slot into the face of the club head. They spread a lot of heavy-duty glue in the slot, and then they plug it with an insert made of rigid plastic. The insert will protect the wooden club head from the force of the golf ball. They trim the overlap, and then they sand it until the plastic insert blends seamlessly with the wood. Using a router, they carve an hourglass shape in the bottom of the golf club head. This big slot will hold the sole plate, which will add weight and protect the bottom of the club. The club head can't be more than 3 grams off the target weight, so they add a lead pellet to make it a little heavier after factoring in the weight of the sole plate that's still to be installed. They drill an extra hole in case they need to add more lead later. Then they press fit the lead pellet to the club head. They slather adhesive in the slot for the sole plate, and then install the sole plate, which is made of stainless steel. Again, sanding smooths away any bumps and grooves. With a drill, they bore a hole in the neck of the golf club head. They slide a glue-coated metal sleeve into that hole. Then they taper the neck with a sanding belt. Using a jeweler's saw, they score the face of the golf club head. These lines are strategic. They'll help give the golf ball spin. They dip the club head in water-based stain that soaks into the wood but doesn't penetrate the metal sole plate. Then, things get messy as they rub a pasty substance all over the golf club head, plugging the open pores of the persimmon wood. It's a crucial step that will allow them to achieve a mirror finish later. They number it to identify it as a fairway club. And then they give the sole plate a good scrubbing with steel wool to get rid of any fingerprints. They spray it with 5 coats of polyurethane. They push the glue-covered end of the shaft into the sleeve in the club head. They adjust the weight by inserting some pulverized lead in the extra hole drilled earlier. For a player to hit balls accurately, each club in the set has to feel as if it's the same weight. So there's one more weigh-in before they decide this wooden golf club is up to par. Now it's time to hit the course, because winning could be a matter of knocking on wood. Aircraft wings provide the lift that takes us to the skies. They're designed to be light, yet very rigid. Producing them requires a strategic balance of old-school production methods and high-tech computer-assisted design. The wing's frame is made up of three main components: the rear spar, the main spar, and ribs. They make the ribs from aircraft-grade aluminum. It's corrosion-resistant and has great tensile strength, allowing it to resist extreme wind pressure. A computer-guided stamping machine punches holes for rivets and control cables. It also stamps larger holes to reduce overall weight. Workers break attachments called microjoints and extract the ribs. Each rib now goes onto a metal and rubber forming die. A hydraulic press applies 150 tons of pressure, stamping the rib to the die shape. Using a grinder, workers smooth out the sharp edges the stamping process left behind. Then they peel off a plastic film that protected the ribs from scratches until now. The factory uses the same process to construct the main spar. The spars run the entire length of the wing. It takes even more pressure this time, 222 tons, to bend the spars into shape. That's because this aluminum is 3 times thicker than what they use for the ribs. To ensure they've aligned the ribs perfectly for riveting, workers manually push spring clamps into the spar. These hold the ribs in position. Workers now hand drill holes for larger rivets, then smooth out the sharp edges with a deburring drill. Then they use a pneumatic riveting gun and bucking bar to rivet ribs to the main spar. They use a tiny bucking bar for some of the tighter spaces. The completed airframe now goes on a positioning rack to receive an aluminum covering they call the wing skin. Workers use spring clamps to position the aluminum top skin onto the airframe. They use the same procedure for the leading edge wing nose. Once everything's together with spring clamps, workers permanently rivet the assembly. Welders, meanwhile, fuse the wing's fuel tank using an argon gas torch. Argon contains fewer contaminants than the typical acetylene torch. They fit the tank into the wing chamber, then secure it by bolting steel belts onto the spars. Now they position the tank's covering plate and screw it onto the wing. These holes are for fuel lines and control cables, which run the entire length of the wing. The wing tip is the final piece they fit and bolt onto the wing. It's made of a lightweight fiberglass and plastic composite. The completed wing is now ready to be bolted onto the aircraft body. Just one aircraft wing weighs a mere 79 kilograms, but it's certainly no lightweight when it comes to strength. It can withstand nearly 2,500 kilograms of wind pressure. Car batteries may die, but that doesn't mean it's the end of the road for the components. These lead-acid batteries are routinely recycled. This keeps toxic materials out of landfills, and it means we get a lot more mileage out of those old car batteries. This battery may be toast, but it's not trash, because dead car batteries are jump-starting a major recycling industry. Pallets of old batteries are tipped onto a conveyor. It takes them up into an enclosed machine that has over 30 rotating hammers. They smash the old batteries to bits, and then a screen filters out the lead-acid paste. The broken bits of lead and plastic tumble into a big vat of water. The lead and other metals sink, while the lighter plastic pieces float to the surface. This system allows them to sort and separate the battery components. The plastic pieces have been cleaned, and a machine now blows them into the back of a truck. They'll be taken to a plastic recycling plant and turned into pellets that will eventually be used in the production of new car batteries. A worm screw now moves the lead and other metals to another part of the plant to await further processing. Remember that lead-acid paste screened out of the smashed-up batteries earlier? The acid has been neutralized and turned into water. This press squeezes the water out, so all that remains is a lead paste. They remove it and add it to the pile of lead and other metals. The water from the deacidification process contains some metallic residues, so they treat it with chemicals that cause the contaminants to precipitate and then settle into a sludge on the bottom of the tanks. They sample the water to make sure the particles are settling properly. They pump out the sludge and then filter the water, which now meets regulatory standards and can be poured down the drain. The sludge goes into that big pile of lead and other metals. They add a few shovels full of refined coal to the pile as a processing aid. Then the battery solids head up a conveyor into a revolving dryer. The metals spend 20 minutes in here to remove any excess moisture. Then it's into a furnace for 10 hours. The lead melts into a liquid and the other metals float to the surface, allowing them to be skimmed off. The molten lead goes into a big steel kettle where it's mixed with caustic soda. This causes some remaining contaminants to float to the surface so they can be removed. The liquid lead is now fairly pure, so it's time to pour. They pump the lead into bar-shaped molds and skim off any lingering impurities. Below, a constant spray of ice-cold water chills the molds, and the lead hardens into bars in just 4 minutes. The conveyor winds downward and the bars are tapped free of their molds. There's enough lead in one of these bars to make 3 car batteries. They'll be remelted and molded into battery components. And the final product is as good as new, proving that recycling can get new life out of that old car battery and in the process, give a boost to pollution prevention efforts.